Today, I want to give a quick story of how CNN evolved from AlexNet to VGG to ResNet. The big idea is simple. AlexNet showed deep learning works, VGG showed depth helps, and ResNet showed that it can solve the training problem that comes with going deeper. AlexNet was the breakthrough moment in 2012. It showed that a deep CNN trained on a large dataset could beat older computer vision methods very clearly. So this was really the point where deep learning became practical for image tasks. One important idea was ReLU, the activation function, and it's written as f of x equals to the maximum of a 0 of x. So what it really means is that positive values stay and negative values become 0. It sounds simple, but this helped networks train much faster than older activations like sigmoid. The core operation is convolution. In simple terms, a small filter slides across the image. At each location, it multiplies local pixel values and adds them up. A large result means that pattern, such as an edge or a texture, is strongly present there. So this basic idea is still central in computer vision today. But AlexNet was still quite shallow by modern standards. Once we make networks such as much deeper, training becomes harder because gradients can shrink too much or grow too much during backpropagation. In 2014, VGG gained prominence for its high performance in the ImageNet competition. VGG took the next step by going deeper with a very simple design, lots of 3x3 convolutions stacked together. It showed that deeper networks can learn richer image features. VGG also showed why small filters are useful. One 7x7 filter uses 49 c² parameters, but 3 of the 3x3 filters use only 27 c². So we get a similar effective viewing area with fewer parameters and more nonlinear steps in between. Now the problem is with deeper networks are harder to train, and during backpropagation the gradient gets multiplied through many layers. If many of those terms are less than 1, the gradient keeps shrinking. So the early layers learn very slowly, and that is what we call the vanishing gradient problem. So in 2015, a group of researchers in Microsoft developed the ResNet architecture to solve the vanishing gradient problem by skipping connection. So instead of forcing every block to completely transform the input, it lets the input flow forward directly through a shortcut path. So the key equation is h equals to f plus x, and here x is the input, f is the extra change the block learns, and h is the output. So the block only learns what needs to be added rather than learning the whole mapping from scratch. This also helps the maths of backpropagation. So that +1 term comes from the shortcut path. It gives the gradient a direct route backward, so it does not vanish as easily. That is why ResNet made very deep networks practical. So the story is, AlexNet made deep CNN practical, VGG showed the power of depth, and ResNet made depth trainable. So even today, these models still matter because their core ideas continue to shape modern AI.